What I'll be doing is giving you another demonstration of how to use PyMOL. And we're going to focus a little bit more on selection and then examples of how we could use selections to analyze structures. So the hope is that you will be able to learn how to use a few commands in PyMOL, right? Which you will discover all center around applying some transformation or characterization of a particular selection. And then that will give you a feel for, so if you work with a few of these, you'll get a feel for how to use commands in PyMOL. And pretty much at that point, the only limits would be your imagination. So what I'll do is just start by going to where I think is the place you can start when you want to learn more about PyMOL or do anything in PyMOL for the first time, right? So there's a PyMOL wiki page. So if you do pymolwiki.org, you get access to this page, and this page contains a wealth of information, and there are tutorials, script libraries. So this is where people have deposited scripts that they've used, and so you can actually reuse those scripts. There are plugins, and so plugins are add-ons or extensions that users have created for PyMOL that allow you to do some kind of analysis, or maybe some kind of special visualization. So these are very often user contributed plugins that extend the functionality of PyMOL beyond the base application. Um, Galleries, covers, then they have the PyMOL cheat sheet, which I gave you, which would be very helpful. And then a lot of people spend a lot of time going to the frequently asked questions because very often you have some kind of question that you want to answer, then you can find answers here. What we're going to do is click on commands. And so there are a couple of commands that we're going to focus on. And so the one initially is just going to be select, right? And so and on Canvas page you got some information about selection, um, and here I'm just this is actually the page that's linked that I linked to in the Canvas page. And so the basic usage for a selection is that you have to issue the select command in PyMOL, and then there's a name. And so the name here is just the object that will be created for your selection. And then you have to use some selection string that tells it what to select. And then there are the options here which you can kind of ignore for now, just to keep things simple. So the good thing about these wiki pages is that they give you very nice, detailed, and consistent layout of the documentation, right? And it tells you exactly what each argument to a particular command is, right? So kind of as I said here, this name, the first thing you supply to the select command is a string, and it gives a unique name for your selection. So that's going to be the unique name is going to be an object that's created. The selection expression, right? This tells it what to select, and then as I said, there are other options. And so here you have a couple examples. And so what we'll do is I'll go ahead and show you how to do this in PyMOL. So go ahead and open a PyMOL, and I suggest that you, as you watch this video, rather than it just being a passive exercise, you might want to kind of follow along. If you need to pause the video, you pause the video and continue. So I like to, because PyMOL tends to download stuff from the coordinate files, I like to go into a temporary directory just initially if I'm not going to save that work. But anyhow, you could skip this step if you wanted to. So what we're going to do is first work with the fetch command again, right? So we're going to go fetch, and we're going to grab this coordinate file with the PDB ID 2KOC. So this is O not 0, so 2KOC. And you get this coordinate file. And again, as you've seen before, the object name shows up on this panel where you have the object menu. And something to notice is that down here, right, you see this state the state tells you the number of states in the object, so it tells you the current state. And so you can actually cycle through the different states. So in this case, what's happening is that this particular coordinate file has multiple entries. And so each entry corresponds to a different state. So there are 20 states in this file. So you can think of states as just being different coordinates of the same system. So anyhow, this one has 20 states. So if you load a file at, for example, if you loaded a typical X-ray structure, right, you typically have one state, and so you would just see, you wouldn't see this 20 here, right? It would be just one. But anyhow, that's not what we're focused on right now. So one of the things I want to do, right, in this example is just kind of focus in on a particular residue because it makes it easy to demonstrate how to use the distance, angle, and dihedral commands. And so what I'm going to do is that I'm going to create a selection, right? So remember the select command is just select, right? And you have to give it a name. I'm going to call it my residue. So that's the name. And then I'm going to tell it what I want to select, right? In this case, what I want to select is residue 1. And so it selects this residue here, which is residue 1. Now, one of the things I want to point out that in PyMOL there are many ways to do the same thing, and so there are many ways to specify a selection. So let me do this. Let me show the sticks, right? So I'm going to change the representation by using the show command, and then I'm going to hide cartoon, which is what you were seeing initially. And so if I was to click on any particular atom, right, what happens is that it tells you in this window here that you clicked, and this is telling you the specific atom you clicked. And the way it tells you, it writes out the string that contains the object name, the seg ID, and if you don't have a seg ID, it will probably be just the chain ID, then the chain ID, then the residue, right? So this is information about telling you that it's a G, the residue name is G, and the number is 1, and then the atom itself. So just to kind of bring this home, right? You can make selections using these strings, right? So here you have seg ID first, then chain ID, I'm just going to call it chain. Then you have so actually, let's start over. Object, then seg ID, then chain, right? Then more information about the residue of sequence, then information about the atom, right? And so what you can do is, in this example here, this object is 2KOC, right? The seg ID, in this file, the seg ID is the same as the chain ID, so it's just A, and then the chain ID is A. The residue, you could specify it either by the residue name and then the number, but you could also just use number here, so I could just say 1, and the name of the atom is just going to be N7, right? So I can actually create a selection. So let's create a new selection. Select my atom is this, right? And it says it selected this atom here. So what I'll do, just so that you can see it, I'm going to show spheres. I'm going to use the command show, and I will tell this show actually changes representations. And I want to show a sphere my atom, the atom I just created, right? And you see it shows up here. So this is a good way to check whether or not you selected what you expected by changing the representation, so it's obvious. Now I'm going to delete this selection using the delete command. So I'm going to delete my atom. And I'm going to now do the same thing, but in this case, since I only have one object name, one object loaded here, I can actually delete this and say, let me select this, right? So it still selects the same atom, right? Furthermore, if I have if there's only one seg ID, I could remove the seg ID, and I'll still select this one atom, which is the same. And if there was just one chain, I could do the same thing. I could remove the chain information and select the same atom again, right? In each case, I'm selecting one atom. Now, adding the additional information about the seg ID, the chain ID, the object, the seg ID, the chain ID gives you more control. So in case you have you have multiple objects with the same atom name, right? You can actually be very specific about which one you select. Anyhow, what I wanted to show you at this stage is that there are multiple ways to do the same selection, right? So I'm gonna go ahead and hide spheres, right? And again, I'm gonna do select my atom, right? And let me delete the current version of this. So I'm gonna do select my atom, and I want to select the same atom. So what I can do, you can write it out more explicitly. You could say seg ID is A, and chain is A. And even further, I could even say, I could give it the object name. So the object name is 2KOC, and seg ID A, and chain A, and res ID 1. So this res ID gives you access to the sequence number, the residue number, and in this case is 1. And to select the atom, you use name, right? So the name of the atom, and in this case, we were looking at N7, right? Do the selection, and now I'm going to show a sphere as that same selection, and the same atom shows up, right? So this is just to demonstrate that there are multiple ways to achieve the same selection, or express the same selection. I typically like this more explicit way, but you can see, look at this, right? I had to write out all of this. That's just how my brain prefers to do things, but it's not the most compact way. It's easy to read because you could tell exactly what's happening, but you might prefer doing it like this, right? So anyhow, so let's go ahead and move on from selections. But before we do that, let's create a selection for the residue. We just want to select residue 1, right? So number of ways I'm going to do this. I'm going to say select my residue, and I could just do residue 1, or I can say, okay, well, I'm going to do object 2KOC, then I'm going to take seg ID A, then chain A, and then I want residue 1, right? And I just select this residue here. Now what I want to do is I'm going to remove everything else. So I'm going to use the remove command, and it's going to remove not my residue, and it deletes everything, all the coordinates for everything else but that residue. And I'm just going to send to the scene so I can actually see this. And I'm going to go about and hide spheres, right? Because we've seen the sphere here. And this is what we have, right? So one of the things that's going to help with the rest of the demonstration is to actually show the atom names here, right? If you click on every atom you see, it tells you what the atom name is, right? But it'll be helpful if you can just visualize that in all of the atom names. So I didn't actually talk much about this, right? But this A, S, H, and L, and C, they have actually meanings, right? This is the action, right? You click on this and you can execute some kind of action. This is show. This is what we use to change the representation. So for example, I want to show spheres. I could click on this, right? I actually want to, or if you want to hide something, you could click on this here and hide. So I'm going to hide the spheres. And then the label is the one we want right now. We could label the atom names. So I'm going to label the atom names, and you should be able to see the atom names show up here. Now the last one is color, which you could use to change the color of the scene. But for now, we just want to keep the scene as such, right? So what we want to do is I'm going to demonstrate how we can measure distances, angles, and dihedrals, right? So first of all, what we're going to do is focus our attention on these four atoms, right? So the O4 prime, the C1 prime, the N9, and then the C8. So this atom here, 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 and here. So let's see how we could figure out. Let's first try to measure the distance between the C1 prime and the N9. So this bond connecting these two atoms here. So if we go back to commands, right? There is a command for get distance, right? And actually, let's use get. So there's get distance. So this is the documentation for get distance. So this is the command get distance, and as it says, returns the distance between two atoms. So the way it works is that you say you call the command, and then you give it the selection for two atoms, and then it returns those distance. So we said we want to calculate the distance between C1 prime and N9, right? So one of the things we can do actually is create selections for these atoms. So let's call this one here atom 1. We call this the C4 prime atom 1. Then we're going to call the C1 prime atom 2. The N9 we're going to call atom 3, and then the C8 we're going to call atom 4. So let's use the select command that we learned to use, and we give it the name atom 1, and the selection would be, we could do it in multiple ways, but let's do it the most compact way now, right? So the object is 2KOC, the seg ID is A, the chain ID is A, residue is 1, and then the atom name is C4 prime, right? So we have that atom, you see it's kind of selected here. Let's create another selection. We call it selection atom 2, and that's going to be the C1 prime. And then we're going to create atom 3, and that's going to be N9. And then atom 4 would be, we said we're going to call C8. So now that we have these selections, we can actually make use of the functions. So we can use get distance, and we said we want to get the distance between C1 prime and N9, and that corresponds to what we had called atom 2 and atom 3. And get rid of this, and there you go. It gives us the distance as 1.46 angstroms. So that's how you use the distance command, right? And just as a sanity check, right, we can also do the distance between, let's say, atom 1 and atom 4. We expect that to be much larger, right? It's because that's that distance between this atom here and this atom here. And so, see, now it's 2.8 angstroms. So using this command, you can actually analyze structure. So let's say you're doing some, you have the structure of some biomolecule, and you want to understand why it achieves a particular function. Maybe it's something to do with an active site, and you want to measure distances between the active site and important atoms in, let's say, the ligand that it binds to, right? You can actually use these kinds of commands. So you can kind of guess now how you would use the the angle, right? The angle command, right? But just to be explicit, right? So we could go back here and let's look at get angle. And so in this case, get angle returns the angle between three atoms, right? And so we need to give it a selection three of three atoms, right? And so let's try this out. So here what we're going to do is calculate the angle between this O4 prime, C1 prime, and this N9, right? So this is that angle between this bond and this bond. So we use the get angle command, and we say, okay, we want to do it between atom 1, atom 2, and atom 3. And that gives us an angle, right? And it makes sense visually, right? So 109 degrees, right? So it's this angle between here and here. And now we can move on to using get dihedral, right? And as you can guess, all we need to do is specify this command is get dihedral, and then we need to list the atom selections as atom 1, atom 2, atom 3, and atom 4. And now we have that dihedral angle, right? And it's about 15 degrees, and that makes sense, right? If you were to look down this plane, right, you can see that the plane formed by these three atoms here, and then these three atoms, the angle is not that much, right? So if you look down, you can see, yeah, that makes sense. The dihedral angle should be very small. Now for all of these commands, right, and most commands in PyMOL, right, if you have questions, right, rather than go, if you already know the command, you can actually get help directly from PyMOL, right, by using the help command. So you say help, and then the name of the command you want to get some help on. So in our case, it's either one of these. Let's say get distance, and the exact same information that's stored on the website is available to you right here. And so it makes it very easy to, provided that you know what a command is, it makes it easy to get information about it. Now, another thing that we didn't talk about is the state here, right? So in terms of these calculations, right? So the default state is 1. So if you have a multi-state object, right, when you run this command, it gives you the result for state 1, right? But if you say state is equal to, let's just see the result when we say state is equal to 1. And if we say state equal to 2, you see you get a different value, right? And so let's cycle to the second state, and you see there is indeed a change, right, in the structure. And so the dihedral changes. So you go state 3, right, and you look at state 3, and you look down this bond vector, it's even smaller, right? So the point is that you can specify which state you want to do the calculation on, and you utilize that by specifying the state here. So it gives you really fine control, especially when working with multi-state objects. So with that, I think we talk about selections, right? And selections are the key to working in PyMOL, especially when you're doing structural analysis. So once you have a handle on selections, then you essentially can do anything, right? It's just a matter of your imagination. So the selection command in PyMOL is very flexible, and we've just briefly kind of touched on what you can do here. But I suggest that you spend some time, and it probably would emerge with as we go along in the course. But if you have a particular biomolecule you're really interested in, right, and you want to analyze that structure, right, I think you want to spend some time looking at the selection algebra page, right? It really gives you a sense of the flexibility of PyMOL, and it's going to go far beyond everything that I'm going to explicitly talk about. Um, some of them may come up, some of them might not, right? But once you are aware of the fact that almost you could come up with very complex selection uh, expressions to select exactly what you're interested in selecting. And so spend some time going through this page, right? So the way you access this particular page, you go to PyMOL Wiki, and then you go to commands, and then you click on select. And you scroll down here, and you see the selection algebra page. And I would suggest that you open up PyMOL and work your way through these examples here. I think they would be quite useful. Now, if you wanted to work through this example, you would have to first load a structure, right? And so choose whatever structure you want and load it in. Let's see. It would have been nice in this example if they had given you a particular system to work with, but you know, you could fetch some particular molecule you're interested in and kind of go through here. Go through this example. Again, you know, there are different ways to write the selections. Again, sometimes you can use shortcuts. So this corresponds to the index number for an atom, then this n dot corresponds to the name. I don't use them very often because I find it difficult to read the scripts, but you can also use that. But you'll learn that by kind of going through this page. Anyhow, if there are any further questions, just send me an email. But I think this should get you on your way in terms of being able to use PyMOL, at least to do some structural analyses.